What is space? Have you ever seen space? We live in space. There is space inside our rooms, space along the streets, and space in the universe where distant stars shine. But when we think about it carefully, something seems a little strange. We can see objects like chairs or trees, but we have never directly seen space itself. So, what exactly is space? For a long time, scientists and philosophers pondered this question. One of them was Isaac Newton. Newton described space in this way. Space is a great container that holds everything. Just as fish swim in water, every object moves within the great container called space. Newton believed that space still exists even if there are no objects at all. He also thought that space does not move and always remains the same, which allows us to explain the motion of objects precisely. Because of this idea, we can build buildings, make bridges, and launch rockets. Even today, much of science and engineering is still explained using this idea of absolute space. But another thinker had a different idea. That thinker was Gottfried Wilhelm Leibniz. Leibniz asked the following question. If there were not a single object in the world, could we still say that space exists? He believed that space does not exist independently from objects. Instead, it comes from the relationships between objects. For example, we might say, this tree is 10 meters away from that building. In this way, we describe space through relationships, such as distance and direction. If that is true, what we call space may actually be a way of describing the relationships between objects. These two ideas were debated among scientists for a long time. Then, in the 20th century, another scientist introduced a completely new idea. That scientist was Albert Einstein. Einstein did not see space as a simple container. He believed that space is something that can move and change. A heavy object can bend space, and when things move very fast, space and time influence each other. It is like placing a heavy ball on a stretched rubber sheet. The sheet bends under the weight. From this idea came the concept of space-time. 3 dimensions of space and 1 dimension of time are connected to form a 4-dimensional world. Because of this theory, we can understand black holes and even develop the Big Bang theory that explains the birth of the universe. But there is an interesting fact. The space we experience in everyday life is still closer to the space Newton described. The speed at which we move is much slower than the speed of light, so we almost never notice space bending or time changing. That is why many of the physical laws we learn in school can still be explained well using Newton's ideas. Isn't that fascinating? We live in space every day, yet the answer to what space truly is still being explored. Perhaps space is not simply empty nothingness. It might be a great stage that connects the universe, matter, and even time. The place where we are standing now may also be just one small coordinate in the vast story of the universe.